All right, we are going to be discussing surface area. Now, right away, people have problem with surface area. Okay? What is the surface area of this vessel as it is viewed to you right now? I haven't taught you what surface area is, but you've been through grade 9. What is, don't give me a number, define for me the surface area of this water bottle. No, that would be the volume. If it was a prism, but it's not a prism. No, none of you can tell me what surface area is. I'll try this. What is the surface area of this room? Again, do not give me a number. Describe it to me. Length times width of what? This room has more than 2 dimensions. This room has 3 dimensions. Pardon me? Length times width times 2. That would cover 2 surfaces of this room. That would cover 4 surfaces of this room. That would cover 5 surfaces of this room. 6. All right. Now, what are those surfaces? The walls, the floor, and the ceiling. Excellent. Okay, we kind of understand what surface area is. Okay. This room has one surface area that affects us, doesn't it? What is that surface area? The floor, the walls, and the ceiling. Yeah? Everyone agrees? Okay. If this room were cut out of the building, would it have another surface area? Yeah. Sure it would. If this room was removed from the building. This is the room in the building. Agreed? The surface area that matters to us is inside this box, yes? Because that's where we live. Everybody with me? If I remove this from the building, is there a different surface area? Where?
That wall.
The outside. Everybody with me? Okay. We are concerned with the outside surface area of shapes. Okay? In Math 9 today. In the real world, what are we more likely concerned with? The inside surface area. Does it matter how we calculate it? Or is a rectangle a rectangle? Monday morning, that was a pretty philosophical question. A rectangle is a rectangle, right? The question becomes not, do we know what the surface area is? The question becomes, what surfaces do we care about? Understand? When in real life would surface area be important, do you think? Building a house. Why?
You need to know how big the room is going to be.
Yes. Why?
Because that's how you build a house.
Okay. Why though? When you build a house, it just looks like a skeleton. How does that surface area matter?
You're going to put walls up.
I'm going to put walls up inside, and those walls are drywall first, and then what? Paint or wallpaper. So you need to know what surface area is, don't you? What goes on the outside of the house?
Plastic.
Siding or paint, right? So you need to know surface area there. Do you put a roof on your house?
Yep.
Do you need to know surface area?
Yep.
Are you putting carpet on the floor?
Yep.
Do you need to know surface area? If you're not putting carpet, are you putting down hardwood? Are you putting down laminate? You're doing something. Do you need to know surface area? Yes. Okay? It has a lot of real-life applications. Unfortunately, it's got too many real-life applications to teach you every possible application of surface area. So what do we teach you? We teach you the theory behind it, and then we ask you to apply it. Right? Which is what I did right here. That's the whole lesson. So, let's get down to business. First thing we got to remember, surface area for our purposes is the outside area of a figure. If I were to pick that figure up and dip it in a bucket of paint, everywhere that paint touches would be the surface area. Do you understand? So, I'll ask again. What is the surface area of this vessel? I just gave you a definition of it. If I pick it up and I dip it in paint, what would the surface area be?
That.
Everything. The outside and the inside. Why? What about this?
There's a hole in the top.
There's a hole in the top. What if I do this? Now what's the surface area?
The outside.
Just the outside. Do you understand? Okay. The next thing we have to talk about is every three-dimensional shape is made up of what? How do I get a three-dimensional shape? What do I have to start with? A two-dimensional shape, of which we know what all the areas are, don't we? Right? If I start with a rectangle, that is how many dimensions? 4 dimensions. This is a magic piece of paper that goes into the 4th dimension. It is technically 3 dimensions because it does have thickness, doesn't it? But for teaching purposes, how many dimensions does this have? 2. A length, which is the length, where my nose is or my fingers are. Where my nose is. The width is where my fingers are. So this has a length and a width, yes? And it only has 2 dimensions. But can I use it to construct 3-dimensional figures? Yes. If I put 6 of them together, I get a box. Right? Cool? So if we can deal with 2-dimensional figures, can we automatically deal with 3-dimensional figures? Yes. So let us move on. We are going to start with rectangular prisms. Now, rectangular prisms are the easiest kind of 3-dimensional figure, but we need to define it first. The reason we need to define it is because when we get to further along in math, you guys will screw up what's a prism and what's not. Okay? So a prism is simply this. 2 identical shapes. Separated by rectangles. Now, if it's a rectangular prism, what do you think is the shape that we start with? A rectangle. All right? I know. It's crazy, right? That's how hard this is, and yet people fail this test. I don't understand it. I'm going to take my red pen and I'm going to outline a rectangle. Has that rectangle been repeated?
Yeah.
Yes. Where? At the back. Everybody with me? And what is separating the two? More rectangles. This one, the top one, the bottom one, and the back, the one on the left. Does everybody get that? So that makes this a rectangular prism, right? It has 6 faces, like a dice, or a die, singular, right? So if it has 6 faces, if you know one face, can you tell me the surface area of this whole thing? No. Why? because you need the sides and the top. Because it's a rectangle, they're not all the same. What if I told you it was a cube? Then you would be okay, right? But this is not a cube. Is a cube a rectangular prism? Yes, a special kind of one. Starts with a rectangle, which is a special rectangle where all the sides are the same, so it's a square. And it's separated by the same squares. So, to do this, I need to be aware of that fact, that there are 6 faces. Now, there's more than one way to go about doing this, like I said earlier, but we're going to do it the long and involved way. Notice how I have given you highlighted stuff. When you are doing this on a test, would I expect you to draw this whole chart? Of course not. But the theory behind it is sound, and you need to be aware of that. The front and the back have been given to you. They are highlighted, front and back. There are 2 of them. What is the width of the front? 6. What is the length? 10 centimeters, correct? Does everybody agree? Yeah? Okay. So what is this guy's area? 6 times 10, which is 60. But how many of them are there? 2. So I got to do 2 times 60 to get 120 centimeters what? Squared. Why squared? Because there's 2 dimensions, length and width. Is everybody okay with that? It's what we did yesterday or Friday. It's not hard, is it? But have I covered every side of this shape? No, I have more rectangles I must deal with, right? So when you are learning to do this, if you are not very good at it, I recommend having pencil crayons or something with me so I can do this. So now, the next one on my chart is top and bottom. So I'm going to do this guy. How big is he? 8 by 10, making him how big? 80. And then what do I got to do? There's 2 of them. So it's 160. Yeah? Easy. You can do this in your head when it's not decimals, can't you? And finally, left and right, we'll do in green. And how big is it? 6 and 8. 6 by 8, which is 48. 2, 48, 96. What do I do with those 3 numbers? Add them up to get what? 376 what? Centimeters squared. Is this difficult? No, it isn't. It's rectangles. Everybody good? Now, of course, as I told you, you have formulas for everything, don't you? And if you look real closely on your formula sheet, you'll see right there is a formula. Right? And right here is the drawing of the prism, yeah? Everybody good? H on the left, L across the bottom, W on the right. Got it? Now go back to your notes. Because there's space at the bottom and on the side. There's a reason for that. Where over here is your H? Look on your formula sheet, compare it to this drawing. Where is the H? Is it 6, 10, or 8? 6. There's the H. Where's the L? Is it 8 or 10? 10 is the L, and what's 8 then? W. Now, if you don't want to do this, you think you're ready to rock, then you can just go ahead and use the formula. Here's the problem. You won't write down the formula and you'll screw it up. Formula is 2WH. I got to do this right. I want to get the right order. WHLWLH. WHLWLH. Right? Everyone agree? What math is happening there? Pardon? Multiply. What math is happening there? Adding. What math is happening there? What math is happening there? What math is happening there? Multiplying. So what do you have to do first, according to BEDMAS? Multiplying. So when you guys try to do these questions, you're going to punch them into your calculator. You're going to punch them in wrong. I know this because I have marked 17 years of math. Kids punch this into their calculator wrong because they don't show their work. What would this be to do it properly and guarantee you did it correctly? 2, first you would do WH. What is W? 8. What is H? 6. Plus, what is L? 10. What is W? 8. Plus, what is L? What is H? Now, to punch that into your calculator, again, a bunch of you are going to screw it up because you feel you can do everything on your calculator. Right? Some of you will be able to do it right. Some of you will screw it up. If you write it down, none of you will screw it up because it's impossible, isn't it? If you write it down, 2, 8 times 6, oh, that's 48. 10 times 8, oh, that's 80. 10 times 6, oh, that's 60. Now what do you do according to BEDMAS? Brackets. Add that up with your calculator. 2 times 188. Now go to your calculator. 2 times 188, 376. I don't care what way you do it. You can use the formula if you want. But the concern I have, it's the same concern I have had every year for 17 years, you will stop listening to me when I say there's a formula. You won't take even a second to think about how that formula works. Okay? And I'm not putting you down. That's just the way, in my experience of teaching 300 kids a month or a year, times 17 years, that is what I have learned from my experience. Please be the first kids that do this right all the time. Hasn't happened yet. Maybe we will get there. So is everyone good? Okay, turn the page over. Now please notice I've given you the chart, which I would never give you on a test. Would this be there on a test? No, it would be a big blank space. But I've also given you enough space to use the formula. I don't care which one you do. Okay? So, I'm going to go ahead and work on this while you guys do too. 5, 2. 5 times 2 is 10, times 2 is 20. 5, 3. 5 times 3 is 15, times 2 is 30. 2, 3. 2 times 3 is 6, times 2 is 12. Then I add it up to get 62. Is everybody good? In a perfect world, I would also right now make sure you can all do this on your calculator from the formula. Okay? Everybody with your calculator right now, write out the formula. Surface area equals 2 LW LHWH, right? Does it matter what order you do it in? No. So 2 times 5 plus 5 times 3 plus 2 times 3. See if you can get your calculator to say 62 in one shot. Try it. Because you know that it's 62, don't you? It can't be not 62, because this was actually easier to do in our heads, wasn't it? Punching this into our calculator is going to prove difficult for some of you. Go. See if you get your calculator in one try to say 62. Good. Was everybody able to do it? If they tried? Some people are still trying, that's fine. I got time to wait. No problem. So here's your next challenge. Look at the next one. What's special about it? It's all 12, right? So it's a cube, right? So, can I do it by writing it all out? Of course I can. Do I need to? No. Because this is going to be 12, 12, which is 12, 12, which is 288, yeah? Do I need to do the rest of them? No, because what's this one going to be? 288. What's this one going to be? Then I can just add them up, couldn't I? Everybody good? Everybody with me? It's not hard, is it? Okay, so what would that be? 864. Now, was everybody able to do this and get 62? Yeah? Okay. Now, the next question is, you guys should have a little bit of blank space at the bottom of your paper, yeah? Okay? I'm going to draw one. You don't need to draw the shape, but here's what I want you to do. Tell me the surface area without writing anything down. You have to do it all in your calculator. Do I make myself clear? Everybody good? Okay. I'm going to draw it. You guys go ahead. I haven't given you any numbers yet, so nobody can be punching keys. Remember, you're not allowed to write anything down. Go. What's the surface area? Without writing anything down. You have an answer for me yet? When you get an answer, touch your nose. You won't know if it's right or not. Just put your finger on your nose. You guys are lame. I'll put my finger on my nose. I have an answer. Then I'll pat my head and rub my tummy. Then I'll switch. Then I'll pet my tummy and rub my head. Then I'll switch. It's harder to do that way. There we go. And none of you lamos still put your fingers on your nose. You guys are no fun. Oh, there we go. What's the answer? Who wants to give me an answer? Who wants to risk it?
47.64.
No.
68.
No.
61.1.
No. Arsh. Pardon me? 83.33. No. You guys all told me this was super easy. You'd all get the right answers.
Can't write down.
Exactly. You can't write it down. So when I give this as a test, what's the first thing you're all going to ask? Do I have to show work? How'd it go for you not showing work on the easiest question I could give you?
Pretty sad.
What was the answer?
81.28.
That's what I thought.
You said 83.
Yeah,
You liar.
I rounded it up.
Nope.
81 doesn't round to 83,
Come on, but 83.15.
which isn't 81.28.
I didn't say that.
Yes, you did.
Liar. You're full of
Yeah,
lies. You got the wrong Stop lying to yourself.
You didn't say 81.3.
You said 83.
You said 83 something.
0.3.
The answer is 81.3.
Actually, no, I think he said 81.
No, he didn't. He said 83.32. Regardless, what is the point of what I just did?
You should write it down.
You can't do this. Even though it's easy, you can't do it without writing it down because you guys haven't practiced enough with either your calculator or with the questions. Do you understand? Now, if you wrote it down, it's real easy, right? Can you still use your calculator to solve these? Yeah. Okay, everybody good? All right. Let's move on, cabbages. Triangular prisms. What is the key word there? Prism. What does that mean? What's a prism? We just defined it like 20 seconds ago. It was a little longer than 20 seconds ago. I'm exaggerating for the sake of emphasis. If I've told you once, I've told you a million times, Riley, don't use hyperbole.
Don't do jokes.
Get it? Exaggerated? Don't use hyperbole. I've told you a million times. Nothing? Nothing?
I get it.
I'm using hyperbole
Get it.
when I tell you not to?
Yeah.
Okay, just making sure. Thanks, Bryn. All right, what do we got?
Try.
Now that I've given you more time to think about it, what is a prism? It's a three-dimensional shape,
Yeah.
which is consisting of what?
A bunch of this.
Two identical shapes separated by rectangles. Now, when it's a rectangular prism, it was two rectangles separated by rectangles, right? So what's a triangular prism? Two triangles separated by rectangles. And indeed, I have that, don't I? Because here is a triangle.
Wow.
Yes?
Yeah.
Here is his partner triangle. And as you can see, they're separated by three rectangles, yes? Easy peasy lemon squeezy. Now, you guys already know that the area of a triangle is that, yes? We've already covered that. Remember, we worked it out. We showed you that a triangle is always just half of a rectangle, yes? But why did we not use length times width anymore? Why did the triangle formula become base times height? Because the triangle will be spun around, yeah? Okay, so everybody can do this, right? Is it still a prism?
Yes.
Yeah.
Okay. So the shape that we start with, there has to be two of them, doesn't it? What shape are we starting with a triangular prism? A triangle. So this shape is really two triangles, and then how many rectangles? Three. Two triangles and three rectangles. Now, what do we notice about those rectangles? Do they all have to be the same? No, they don't have to be the same. So really what we have here is two triangles, three rectangles. A triangle is 1/2 base times height, isn't it? And a rectangle is LW, yeah? So really what I have here is 1/2 base times height for the triangle plus LW for rectangle 1 plus LW for rectangle 2 plus LW for rectangle 3. Right? Does everyone agree? Length times width. Everybody good? Okay. So now, again, we're going to do this the old school way first, then I'm going to give you a shortcut. Okay? So, what is this guy's base and height? 8 and 6. Agreed?
Yeah.
So this guy is, how many triangles are there? 2. So it's 2 times 1/2, 6 times 8. Correct? What is 6 times 8? 48. What's half of 48? 24. What's 24 times 2? 48. I know, right? We're back to 48. Why? There's two triangles. So this triangle mixes with this triangle, right? And what do you get? A rectangle that is 6 by 8.
There's no portion divided by 2.
No.
No, you cancel that out and you just go with that. Does everybody see that? It's slick, right? It's algebraic. Can you do this the long way?
Yeah.
Sure, we just did it. But can you save yourself some time by saying, oh wait, two triangles makes one rectangle, so I can just do length times width, can't I? Right? That's the shortcut gift I gave you. Now, look at this one. It's this rectangle. How long is this side? 10. So how long is this side?
Oh wait, what side?
10. Excellent. How long is this side? So how long is this side? So how long is this side? 4. How many of them are there? 1 in this case. In rectangular prisms, how many would there be? 2. But in a triangular prism, there's only 1 because the 3 triangles are different. So this guy is what? 10 by 4 to get 40 for that rectangle, right? What's this guy on the back? We already know across here he's what? 4. Do we already know his height? What is it? 6. So I got 6 and I got 4. What's this answer then? 24. And what's the bottom? 8 by 4. And then what are you going to do with all those numbers? Add them up to get what? $144. 144 what? Centimeters squared. Now, guys, look closely at this. This shape here, I'm going to erase all the colors. What if this were missing? Could you still do it? Why? Six, 8. Pythagoras. Everyone forgets Pythagoras. Dab longer than that. That's important.
No, you
You don't have to do a secret
can't
dab.
have a long dab.
Sure you can.
You can't.
Sure you
Do a
can.
long dab. That's a slow motion dab. That's the opposite way.
It's not a dab.
What do you use, Usain Bolt?
It'll do. Because you guys see a mirror. It's a mirror. You reach to the windows. So I reach to the windows because we're a mirror of each other.
Yeah, but I look this way.
Yes,
So
but
you look this way.
I wasn't going to look because I was looking at you people.
So you're looking that way. Take this L.
Pythagoras. Will you forget it? Yes.
No,
Yes, you will.
I already remember it.
You will forget it.
A squared plus B squared equals C squared.
Great. You will forget it. But we'll come back to that later. Go. Do that one. Yep. Yep. Are we all good? What's the only way I could make that more difficult? Is if I took that away, correct? So then what would you do? Pythagoras. Remember, if you're missing a measurement, not necessarily, and I'll tell you why in a sec. Sometimes you need to figure it out. Because it's not. That's 8 times 12. 9 times 12 is 108.
Because it's the half.
Because I'm a dummy and I did it in my head.
Oh.
9 times 12 is 108. So you need to add 12 to that to get 288.
I thought it was just
You
degrees or something. Yeah.
Oh, yeah, that's a new difference in that.
Thank you, Bryn.
Yeah, great.
Okay? Everybody Gouda?
Great. I like the word five figures. Five figures. My growing one.
Okay.
This one. A square.
No, it is
Rectangle.
not a square.
Rectangle.
Wrong. It's not a rectangle.
Paper.
Wrong.
It's a prism.
It is a prism.
Triangle.
What prism?
Rectangular.
No.
A triangle.
No.
A square.
No.
Circular.
No. It is a circular one.
Oh my god.
No.
Cylinder.
It's a cylinder. What is a cylinder? A rectangle. A rectangle plus what? A circle?
Two circles.
Two circles. Right?
Yeah.
So what is the surface area of a cylinder? A rectangle, which is length times width, plus two circles, which are what? What's the area of a circle? If only Mr. Myers had given me a formula sheet.
Pi r squared.
Pi r squared, but there's how many circles?
2 pi r squared.
2 pi r squared, right?
Right. Because I said it.
So, once again, we come back to this. Now, here is where you guys start screwing stuff up. Okay? And I'm going to tell you why in a minute. First of all, we're aware that a cylinder has two circular faces. So it's two circles, which means it's 2 pi r squared, yes?
Yes.
And it's one rectangle, which is LW, isn't it? Right?
Yeah.
Right?
Yeah.
Now draw what it would really look like. There's a circle, right? And there's two of them. So we're going to put one on the top and one on the bottom. And then in the middle is this rectangle, yes?
Actually drew a cylinder.
Is everybody with me?
Yeah.
So this is the W of the rectangle, isn't it? But what is it the way we usually draw a cylinder? Because we usually draw our cylinders up and down, yeah?
Circle.
Right? That's how we usually draw a cylinder, agreed?
Yeah.
So it's really the width of the rectangle becomes the height of the cylinder, right? Until I mess with your heads and draw a cylinder this way.
Same thing. Oh, messy.
It messes with you. You laugh, Perry, but I've had kids give me this answer wrong. They say, this is the height.
No.
Of course not, because that's across a circle, which makes it a diameter, doesn't it?
Yeah.
So that's the first mistake you're all going to make. But here's the real problem. What's this distance? On the rectangle, it's L, isn't it?
Width.
What is it on the circle?
Circle.
It's the circumference of the circle, isn't it?
That's what I meant.
And we know that the circumference of a circle equals what? Pi d, don't we? Pi times the diameter gets me the circumference. We did this on Friday. You weren't here, right? What else do we know about d? D equals 2 r's, doesn't it? So does that not mean that the circumference can equal 2 pi r? 2 r's and a pi. Does everyone agree?
Yeah.
And circumference also equals the length of the rectangle. Right? So that must mean that a surface area of a cylinder has 2 pi r squareds, that's the circles, plus 2 pi r h. 2 pi r gives me the length of the rectangle. The h we know is the width of the rectangle. Everybody with me? Difficult to punch into your calculator. We'll talk about that in a minute, but first we're going to write it down. The top and bottom are circles, yes? Which is pi r squared. What's the r? The radius. Half the distance across. Do you always know the radius? No, sometimes you're given the diameter, so what do you got to do? Divide by 2. That's on you guys, right? Now, how many of them are there? 2, because there's a top and a bottom. So the area is 2 pi r squareds. Right? Then the curved surface just makes a rectangle, which we know is LW, except W is the height of the cylinder. And L is the circumference. Right? And we know that the circumference is 2 pi r. Right? So this guy, if the L is really 2 pi r, and the W is really h, then this is really 2 pi r h. And then what do you do with those two numbers? You're going to add them together. So the formula becomes 2 pi r squared plus 2 pi r h. Good? Again, difficult to punch into your calculator in one shot. Okay? So let's practice it a little bit. What do I have there?
A cylinder.
Great. I know the formula is what?
2 pi r squared.
2 pi r squared plus 2 pi r h. Agreed? Let's do it the long way first. What's the r in this circle? 3. So it's going to be 2 pi times 3 squared, yes? Agreed? Now listen to me. After grade 9, do I want to see that pi there?
Yes.
After grade 9, I do. So what is this answer? After grade 9, what do I do first?
2 pi.
No.
What's the question?
After the 9th grade, we are not going to get rid of pi. So we got to leave pi in the answer. So what do I got to do first there? Multiply, multiply, or exponent? Exponent. So what's 3 squared? 9. So this is really 2 pi times 9, isn't it? Now, if we're leaving pi there, the only thing I can do is 2 and 9, yeah? What math is that? Multiply. So this is really 18 pi. Agreed? Everybody cool with that?
Yeah.
Now we know that's got an approximate numerical value, don't we? Because we would go 18 times pi button and get the answer, yeah?
Sure.
Okay. What's this one? 5. And what's up here? 2 pi r, yes? So 2 times pi times what's my r? 3. What's 3 times 2? 6. And what's 6 times 5? 30. So this would be 30 pi, wouldn't it? And then what do I do at the end? Add them up. I got 18 pi's there, I got 30 pi's there. How many pi's is that?
48.
48 pi. And that's your grade 10, 11, 12 answer. Got it?
You don't have to
It's not your grade 9 answer. What's your grade 9 answer? What are you going to do at the end?
round it.
You're going to multiply that. You're going to go to 48 pi in your calculator. But before you touch your calculator, what are you going to do? Starts with an E. Ends with an E.
Estimate.
Has stimat in the middle of it. Estimate. Is that close to 50? Is pi close to 3? What's 50 times 3? 150. So your answer had better be close to 150, right?
50.79.
So I go, my estimate is 50 times 3, which is 150. Now I go to my calculator, I do the work, and what do I get, Riley? 150.79. Does everybody see how it works? If there are no decimals, I really recommend leaving it as pi until the end. If there's decimals, can you do that? Not really. You got to do it step by step, don't you? Right? But I would still leave it as pi at the end. Okay? Here's what I mean. If this was, first of all, punch this into your calculator. 2 pi r squared plus 2 pi r h. See if you can actually get the right volume. So it's 2 pi 3 squared plus 2 pi 3 times 5. Punch that into your calculator and see if you get 150.79. Make sure you can do it in one shot without writing anything down. Because now that you know what the answer is going to be. Yeah? Is everybody able to do it? There's a reason I'm doing this to you guys, trust me. Was everybody able to get 150.79 when they punched it in all at once? You got it this time? I believe you, you just have to say yes. You got it this time? Okay?
Yep.
Everyone's able to do it? Okay.
Captain Underpants. Who remembers those books?
Go ahead. Do you have to fill in the whole chart?
No.
No, you don't have to. You could do this. 2 pi r squared plus 2 pi r h. 2 pi, what's my r? 4 squared plus 2 pi, what's my r? What's my h? 6. What's 4 squared? Times 2? 32 pi. Plus, what's 4 times 6? Times 2? 48. 48 pi. What's 32 pies and 48 pies?
A lot of pies.
80 pi. What's my estimate? 80 times 3, right? 240. So then you would do your answer. I estimate 80 times 3. I do my answer. What is it? Shouldn't be that hard. Shouldn't be taking this long. $251.33. I estimated 240. I got 251. I'm happy with that. Right? Everybody good? Now, if you were filling this all out, okay, 2 pi 4 squared, I would still say 32 pi there. Right? That's what I would do. If you want to punch this into your calculator all the way along, that's fine too. Okay? But remember to show your work. Everybody good? Yeah? And then what would this one be? 2 times pi times r, which was 4, times h, which was 6, which would have been 48 pi. Cool? Okay. I am done. Now, I think, if I'm not mistaken, we are at this worksheet spot here, which I don't think you guys have in your book. No, that's your next set of notes.
Down.
Yeah, you guys don't have that, do you?
I don't think so. Well,
You don't have a worksheet that's 3D. No, the next thing in your notes should be this. Is that the next thing in your notes? Yes, okay. You need this worksheet.
We do not have.
That is what you do not have. Okay, now you will notice this worksheet is all two-dimensional. Why?
Why are you looking at me?
It's harder to do the equations.
What?
It's harder to do the stuff.
Yeah. Okay.
I'm crazy.
I don't know why you guys don't have this. You can see it's here. All I do is for these is go click, click, print all, but this for some reason is not in your book.
No.
Okay? So I'm going to print this right now. Okay? It'll take a moment. So you can talk amongst yourselves for a moment.